Okay, guys, a little quick fun with vectors. So you've been reading about vector addition, and it gets entertainingly complicated there with the use of the trigonometric functions to determine the uh, vertical and horizontal components of the vector in order to get the actual an actual way to add up those components. And then you looked at the graphing, which was a little bit easier. Okay, so I'm not going to particularly get into a detailed use of those. We're going to look at it more so in the graphical sort of sense. But we're going to look at the use of vectors to kind of analyze some everyday physics. So the first one, you are going down the street, right? So there's your road, here's your car, and I am not trying to draw this with any kind of great skill. So just so you can tell which way is which, heading that way, right? Got this very large vector going in that direction. Okay? Boom, your tire blows. And now you have no front right tire. What does that do? You all of a sudden have no friction on one side holding you in the road, plus you're dipped down. It creates a vector of force pulling you that way. Okay? So these two vectors combined, right? If we went and looked at them, I'm just going to be kind of rough here in my description or my drawing of them. One there, that's going to pull you to the side, somewhere you don't want to be. Okay? How do we correct for this? Well, there's two things you can do. Number one, you can turn your wheel the other direction in an attempt to create a vector to pull you back straight. However, that being everybody's first choice naturally is not necessarily the best one, because you only have one wheel grabbing the road. So the amount of friction you're going to obtain by turning to the left is not going to be as much as you think, and then people overreact, and then once it grabs, you spin the other way out of control. A little bit of turning your wheel is fine. But in conjunction with that, the best choice is to increase your forward vector. In other words, put the pedal to the metal, at least for a brief burst to get control. What does that do? Well, if I have a much larger vector this direction, I've got my side vector, but that is diminished slightly by me turning. Now, I only have this tiny change in my overall direction. So, using this vector analysis, you can see why it's important that if you blow a tire out, to hit the fuel. Okay, there's another scenario with driving that using vectors makes a nice analysis. So I'm going to grab my eraser that probably won't work too well. No, not too well, but well enough. Okay, so you're going around a corner. And again, I'll draw a road here. Okay, it's a real rookie mistake to go into a corner too fast. And then what does somebody do when they go into a corner too fast? Usually the wrong thing. Usually they hit the brakes. Okay, so if I'm going into it fast, right, I'm going to draw my vectors off to the side here instead of drawing them there. So if this is my car, right, just going into the corner, I've got a very large vector to the side here. And the other vector that I have my road friction, right, with the wheels trying to turn, okay? So I've got friction that is pulling me this way. And that's how I am maintaining this corner. Now, so you've got this forward momentum here, or this forward vector, and you've got this, vector turning, it's creating a your vehicle is now taking the corner, right? The combination of those vectors. So when you hit this corner, your vehicle is moving this direction around the curve. That original velocity when you hit this corner is determining how your vehicle will behave as you are accelerating it through this corner. By accelerating, I mean changing direction. So we're jumping ahead to some of Newton's laws as far as an object wants to maintain its speed and direction, if at all possible, inertia, right? So we're going to change that going through this corner. Now, when you're traveling around a circle, we tend to interpret the forces as the centripetal force and the centrifugal force. So here's P and F to represent those. Now, the centripetal force here, right, is caused by the fact that you have this inertia in this forward direction, right? So this car right here wants to keep going this way as you are going around the corner. That's where the large majority of the force is at. You have this little tiny force in your wheel turning to the right, but what's really helping you stay on the road is the friction of the road. So you've got this centripetal force pushing you off. The centrifugal is the friction. Now, here's the thing. If you're going into a corner too fast, sometimes it's better to just hang on and go through the corner. Because if you hit the brakes and reduce this, okay, that is increasing the push off the corner. Because this forward momentum, now remember this was, from us starting into it. This forward momentum, you have this forward momentum. And you want to keep pushing forward. If you are, let's say you've gotten to this point, okay, and you decide that's too fast, so instead of having this long vector pushing behind you, you shorten that vector as much as you can by hitting the brakes. At the time being, this has the potential to overwhelm your vehicle, and you lose control and go off the road. In fact, a lot of race car drivers will increase their forward momentum just a little bit with a forward acceleration as they're going through a corner in order to make sure that they increase their friction and increase the forward push all at the same time so that it overpowers that centripetal force. Yeah, this one's a little bit more complicated and harder to do with vectors, but I just wanted to show you some of the practical applications of looking at these vectors in your everyday life. Oops, I went and reviewed my analysis here and realized I made a rookie error here. This right here is your centripetal. And this right here is your centrifugal. And an easy way to remember which is which is that the centripetal force is the force that is drawing you to the point. In other words, if I would consider this to be a radius right here, right? If it was a string, the centripetal force would be the string holding me to that point. It's also why I mislabeled them, because I was thinking the point down here connecting up to here. But the centripetal force draws you to the point. The centrifugal one is the one that is pushing you away from the point. So, my apologies.